class. So today we are going to start a new topic. But before we start, like always, we are going to start it in a fun way. We are going to have a quiz. Okay, two questions before I start the main topic. Are you all ready and excited? Very nice. So I'll start with my question. The first one is you have to guess the figure. Okay, I'll be giving you some hints and you'll have to guess which figure I'm talking about. Okay, so I have three corners and three sides. The figure is telling you that I am having three corners and three sides. So which figure am I? Can anyone guess? Yeah, very nice. The answer is triangle. As you can see, triangle has three sides and three corners. Perfect. Now the second one, I am triangle's friend, but I don't have sides and corners. Can you guess who am I? So you have to guess a figure who is triangle's friend, but the friend is not having sides and corners. Which figure can it be? Yes, your guess is correct. The figure is circle. Circle has no sides and no vertex, right? Perfect. So, can you guess what is today's topic from this answer? Yeah, correct. Today's topic is circles. We have already studied circles basics in our lower grades. So today we are going to learn more in deep about circles and properties of circles. Okay, so before we start with the main topic, we will be revising some topics that we have already studied in our lower grades. Some definitions and some terms related to circles we are going to study. Now, why do we are learning these circles? Because if you observe your surrounding, you can see many objects that are in circular shape, right? We deal with many objects that are in circular shape in day-to-day life. Yes, so you should need to know the different properties of circle. It can be area, it can be perimeter, it can be many other things. So now let's start and revise the basics of the circle. Okay. So my first question is I want you to observe this figure and then you are going to tell me you can see this is a circle, you have a center, you have a radius, you have a diameter, you have a chord. So I want one of you to answer what is the center point, what is the radius, and what is the diameter, and what is the chord. Okay, and then the difference between diameter and a chord also. Yes, correct. O is the center of the circle. AB is the radius. No, AB is not the radius. What is the radius? Can anyone else answer? Yes, OP and OQ are the radius. And AB is a, yeah, right. AB is a chord. And what about PQ? PQ is a diameter. Perfect. So now let's revise this in a more proper way. Okay, so coming to
A line
radius.
joining center of the circle and any point on the circle is known as radius of the circle. Distance between the center of the circle and any point on the circle is always constant. This constant distance is known as radius, denoted by r. A line joining center of the circle
Okay, so
and
radius
any
means
point
what?
on the
Radius
circle
will be a
is known
line
as
segment that is
radius
joining
of
your
the
center of the
circle.
circle and any point. It can be any point on
Distance
the
between the
circle.
center of the
And we
circle
denote
and
radius
any
by
point
r.
on the circle.
Next.
Diameter. Diameter is special type of chord. Chord passing through center of the circle is known as diameter. Diameter is the longest chord on the circle. Here you can see DP and AB. Both are the chords, but diameter is the longest chord on the circle. Diameter divides the circle in two equal parts. Diameter is denoted by D. Diameter.
Yes. So a
Diameter is
diameter
special
and a
type
chord.
of chord.
Chord, both the points,
Chord
line
passing through
segment,
center
a
of the
line segment
circle
whose
is
both the
known as
endpoints are lying on
diameter.
the circle. On the circle is your chord.
Diameter is the
Okay, and
longest
now
chord on the
as we
circle.
have
Here
seen
you
that
can see
diameter is a special
DP
type
and
of chord.
AB.
Why
Both are the
special? Because
chords,
it is
but
passing through
diameter
center
is
of the
the
circle,
longest chord
and you can see
on
in
the
the figure that
circle.
it is dividing the circle in two
Diameter
equal
divides the
parts.
circle
Okay,
into
and it
equal
is the
parts.
longest chord on the circle.
Diameter is
Then
denoted
the
by
main
D.
important one, tangent and
Diameter.
secant. Can anyone tell me
Diameter
what
is
is the
special
tangent?
type of chord.
Yes,
Chord passing through center of
intersecting
the
the circle
circle
at one
is
point.
known
And what
as
is the secant?
diameter.
Intersecting the circle at 2 points.
Diameter
Perfect.
is the
Let us
longest
see
chord on the
it in
circle.
details.
Here you can see the circle at exactly one point is known as tangent. Here line is intersecting the circle at point P. Intersecting the circle at exactly one point is known as
So
tangent.
if you can see the
Here
picture
line is
properly, you can
intersecting the
see we have
circle
a
at
circle
point
with
P.
center
Intersecting
C,
the circle
a
at
point
exactly
P
one
on the
point is
circle,
known as
and there is a
tangent.
line which is
Here
intersecting the
line
circle
is
at only
intersecting
one
the
point, that
circle
is
at
P.
point P.
Okay,
Intersecting the
so
circle
any
at
line that is
exactly one
intersecting the
point
circle at
is
single
known as
point,
tangent.
we are going to call it
Here
as a
line is
tangent.
intersecting the
Tangent to a
circle at
circle
point
with
P.
center
Intersecting
C,
the circle
and it
at
is
exactly
intersecting the
one
circle
point
with
is known
on
as
point
tangent.
P. Okay,
Line intersecting the circle at 2 points is known as secant. Here line is intersecting the circle at point P and Q. Line can intersect the circle at maximum 2 points. Here in the diagram you can see each line is intersecting the circle at only 2 points. Line
yes.
intersecting the
So
circle at
here
two
we have
points
seen
is
that
known as
any
secant.
line can intersect the
Here
circle
line is
in two
intersecting the
ways.
circle
Either
at
one
point
point,
P and
if it
Q.
is intersecting at one point, we will call it as
Line
tangent.
can
If it
intersect the
is
circle
intersecting at two
at
points, we are going to
maximum
call
two
it as
points.
secant.
Here in the
And
diagram
any
you can
line can
see
intersect the
each line
circle at
is
maximum
intersecting the
2 points,
circle
not more
at
than that.
only two
Yes,
points.
and let us revise the
Line
area
intersecting
formula
the
for the
circle
circle.
at
What is
two
the area of the
points is
circle?
known as secant.
Area is pi r
Here
square.
line is
So this was a
intersecting the
basic
circle
that
at point
you all
P and
know and
Q.
we have already studied in grade 9.
Line
Now
can
we'll go to
intersect
the
the
next
circle
topic
at
where we will
maximum
learn
two
some
points.
properties and
Here in the
theorems.
diagram you can
Okay,
see
now so
each
when
line
the
is
topics are
intersecting the
clear, we
circle
know what is a
at
chord,
only two
we know what is a
points.
tangent, we know what
Line
is a secant.
intersecting the
Now
circle
we'll
at two
learn different
points is
properties
known as
of this.
secant.
Okay, so today's
Here
class we are
line is
going to learn one
intersecting the
property
circle at
related to
point P
chords.
and Q.
So what is a chord, kids? Yes,
Line
a
can
chord
intersect the
is a line
circle
segment
at
whose
maximum
both the
2 points.
endpoints will be
Here in the
on the
diagram you
circle.
can see each
Perfect.
line
So
is
let's see
intersecting
the
the circle.
property. Okay, so the first property of chords is a perpendicular from center of a circle to a chord bisects the chord. I'll repeat, a perpendicular from center of a circle to a chord bisects the chord. Means if you draw a perpendicular from the center of a circle, okay, that is a radius. It's, if radius, what is radius? Radius is a point whose line segment whose one point is center of the circle and other point is on the circle. Okay, but here what is given? A perpendicular from center of the circle. So the one point will be on the center of the circle and second point is on the chord. You can see one chord over here. So that perpendicular from the chord to center of the circle. Okay, so this line is going to be smaller than your radius. So here you have to prove that that perpendicular is bisecting the line in two parts. What we have to prove over here? That the line is bisecting the chord. Bisecting means what? Can anyone tell me what do you mean by bisecting? Yes, bisecting means you're dividing the line into equal parts. Perfect. Okay, so from whenever you have to write a theorem, first understand the statement. Okay, I'll read the statement once again. A perpendicular from center of a circle to a chord bisects the chord. So after reading the statement, next part is drawing the diagram. So we'll draw a circle. We are going to draw a chord. After drawing a chord, we need to draw perpendicular from the chord to the center of the circle. Okay, and now what we need to prove that the perpendicular drawn is bisecting the chord. Bisecting means dividing it into equal parts. Perfect. So now Few steps that everyone should always remember when you're writing a theorem. First, the statement will be written. Second, you need to draw a diagram. Diagram is always necessary for theorems. Then you will write it in a format like given, to prove, construction, and your main proof. Okay, so now let's see what is given. Can anyone tell me what is given in this? Yes. What is given? That we have a perpendicular from the chord to the center of the circle. So we need to do the namings. So you can see on the board that I have drawn a circle with center O. I have taken the chord as naming and I have given them the naming as A and B. Okay, so I will write it as segment OB is OP is perpendicular to AB. Okay, segment OP will be perpendicular to AB. AB is my chord, OP is my perpendicular. So now what do I need to prove here? I need to prove that segment AP is equal to segment BP, or we also say it as seg AP is congruent to seg BP. Congruent means having same value. Yes, we have seen this. So this is the second step that we'll do. After writing given, what are we going to write, kids? Yes, we are going to write the to prove. What are we going to do in this? First, you have to identify the given. Second, you need to identify what are you going to prove. And then third, use all the things that is given to prove the given thing. Now, sometimes all the given things will not be sufficient. We may need to do some constructions. Okay. Now, here to prove that segment AP is equal to segment BP, we need to draw two segments. That is, we need to construct a triangle. So, we are going to draw AO and OB. Okay, constructing segment AO and seg OB. One point to remember over here, whenever you're doing some construction, always show it with the dotted line and you have to mention it as construction. Okay, it was not given, you are constructing it, so you have to mention it at construction. So after writing that, now let's start with the proof. Yes, so here what are we going to prove? That segment AP is congruent to segment BP. Now I have drawn two triangles. Can anyone tell me why I have drawn triangles? Yes, so that we can use a congruency and try to get the two sides equal. Perfect. So what should be my first step? I'll write in triangle. Which are the two triangles? Can anyone tell me? Yes, it is OPA and OPB. So I'll write in triangle OPA and triangle OPB. Okay, now is anything same in these triangles? Yes, perfect. We are going to use the given that it is a perpendicular. So you will have angle P as 90 degree. So what are we going to write? Angle OPA is congruent to angle OPB. Perfect. Okay, so that is the first point. You got one angle equal. Anything else that is common or equal? Can anyone guess? Yeah, the common thing is the sides. Yes, side AO, or you can say yes, seg AO congruent to OB. Yes, but why they are equal? Will you tell me the reason? Perfect, because they are radius of the same circle, and radius of the same circle are equal. We have just now revised that. Perfect. And always when you mention that they are AO is equal to OB side, you are going to write the reason. Like first, I have shown that angles are equal. Why they are equal? Because they are the lines are perpendicular, right? So you will always mention the reason on the side. Okay, whenever you write the points like angle AOP is equal to angle OPB. Side by you have to mention the reason why they are equal. It can be given or it can be some property that we are using. AO equal to OB, this is because they are the radius of the circle. So I have mentioned it. Okay, so that is important to mention the reason how we are getting it equal. Anything else that you can see common, because you everyone knows that to prove a triangle congruent, how many criteria we need? Yes, perfect. Three. So we got two, one angle, one side. What else do you have common or equal in these triangles? Observe and tell me. Yes, perfect. Segment OP is equal to segment OP. This is the same side of the triangle, both the triangles. The side that is common to both the triangles. Perfect. So how will we write it as? Segment OP congruent to segment OP. And then the reason will come as common side. Very nice. Okay, now we got three conditions, the three things: one angle, two sides equal for two triangles. So from this, what can we conclude? Yes, we will conclude that triangle OPA is congruent to triangle OPB. Very good. And what is the criteria to prove them equal? Very nice. That is side angle side test. SAS test. By side angle side test, we put two sides equal, one angle equal. Yes. And now using the congruency criteria, what is the next step that we are going to get? Perfect. Segment AP congruent to segment BP. That is what we had to prove, right? We had to prove it equal and we have got it. Yes. Let's revise the proof in short once again. What is the property of a chord? The property is, if you draw a perpendicular from a chord to the center of the circle, that perpendicular is dividing the chords into equal parts. Or you can say that the perpendicular is bisecting the chord. Yes. So what are the steps to prove it? First, we will draw the diagram, we'll write the given, we'll write two proof, and in main proof we are taking two triangles and we are proving it congruent. And using the congruency criteria, we get the two sides, that is two parts of that chord AB equal. Yes. So this is the way to prove this theorem. So we'll always remember this property, that a perpendicular from the center of the circle to a chord bisects the chord. I hope everyone has understood it. In next class, we'll be seeing the next property. Thank you.